Hi, this is week 7, and let's continue with our topics from natural language processing. This topic is about information extraction and name identity recognition. So, information extraction systems find, understand limited relevant parts of text, gather information from many pieces of text, produce a structured representation of relevant informations, relations in database, etc. So it is getting some insights from information. You want to get some data. Mm, System extract clear factual information. Who did what to when. So, for example, you have big text and you want to understand from text who was, when was specific person born, and for example, the age of some person, the name, or his who is his father, where he works, and etc. So, for example, imagine that you have some essay, and from that essay, you should. There are millions of essays about how the people want to be student of some specific university, and you gather information, and then you want to understand who is what specific information for that. Low-level information extraction. Also, this thing can be used in Siri like chatbots. So, for example, you say something, you ask from something like Alisa or something that who was born at that time. So this is also information extraction. Or, for example, learn drug gene production interactions from medical research literature. So imagine that there is information, medical papers for medical industry, medical research, and there are many like experiments, and you want by combining all of them, you want to specify what was the thing. Low level information extraction. So you have, for example, mail, and it can find, for example, dates. So this is very simple because it finds the date, and then says, okay, let me create this date, and then it will write. It can create you a specific event, like calendar event. Also, beach, you see here some BHP belong headquarters, and it specifies it. It emphasizes it, makes it bold, and you see that it understands that actually you are searching for Billiton headquarters. So you have company which is called BHP Billiton, and headquarters is where it is located, and it specifies it. So headquarters is some location, it understands it. And also the specific sub important task, it's called name entity recognition. It's like mostly used some subtasks. Mainly, maybe you will not use it in directly, but it's very common to make, first of all, name identity recognition, and then you make something different. So, for example, you want to write some spell recognition, and you say you do not need spell recognition if it is name of person, because the name of person can be different, and it can be not in some text. So, for example, this is text, and you want to find name identity recognition. So name identity recognition is something like this. When you say that it finds that Andrew book is mostly name identity recognition. Name entity is some specific name, like place or person or organization. So it finds out that, for example, this one, Wilkie, Rob, Oakshott, Tony Windsor, and Greens agree to support labor. So this is very common task. How you can do this? So, for example, you can say Andrew Wook is a person, date is this one date, location, okay, for example, Okay, there is no location, and there is organization, etc. The user's name identities can be indexed, linked off. So you can, for example, create link for this. You have text, some news articles, and you want to make like links. So, but you don't want the editor to make links, but editor of the company will suggest it to editor. So he, for example, write some text, and you want to make some links to these specific topics. So you can use this. Sentiment can be attributed to companies or products. A lot of IE relations are associated between name and sentiment can be attributed to companies or products. So for example, if you find out name identity recognition, name of person, company, so you can specify who is liked or who is not liked. For example, you find the company like Adidas and you see some word bad or good, and you can make it some give some sentiment. A lot of information extraction. So mostly when you search something with, for example, Siri or Alisa, you search between some named entities, like who was the king of England in 18th century. So actually you are searching for some name and for its relation to country. Question answering. So actually I made this one. Many web pages tag various entities, which links, bios, or topic pages, etc. Okay, so this is like very task. The formulation, you have some text. Foreign Ministry spokesman Chen Juafang told Reuters, and you want and you classify it by using this text org. This O means other, person, or organization, etc. Recall precision for tasks like here and task address where the measure behaves a bit funnily, where there are boundary errors. So for example, First Bank of Chicago. So actually, as I understand, the First Bank of Chicago, it is name of company. So it's total name. Like you can say Nazarbayev University, it can understand that Nazarbayev is a person, but actually Nazarbayev University is not person but organization. This counts as both FP and FN, so same for Süleyman Demirel University. This counts both as false positive and false negative. So when you classify it, if it can be considered as, so this first maybe it was about first, or it may be about the actual name is First Bank of Chicago. Select would have been better. So this is about how to classify them. Well, not maybe deep into these subjects. The ML sequence model, so collect set of representative training documents. So how you use it as in machine learning. With machine learning, solve this problem. You collect data, label each token for its entity class or other O. So you say that okay, we specify this something that not named entity, you specify by O, it means it's other. Design feature extractors for appropriate for the text and classes. So this is important thing. So you extract features. You want to, there should be some features. How to find this one? Train a sequence classifier to predict the labels from the data. So for each token, you make some list of features, and then you make sequence classifier to predict the labels. At this testing, user receives a set of testing, run sequence model. So this is like training. You get testings, check on each token if it shows correctly, and then calculate precision, recall, accuracy, and etc. And also this is two types of encoding. So how you specify these things. So for example, this is thread. This is IO encoding, this is IOB encoding. The difference is that this one says that B person. Why B person? The difference is only here. I person, because I forgot this abbreviation, but it means that this is continuing. So Fred showed Sue Minkyu Huang's new painting. So actually Minkyu Huang is some person, and B person specifies that this is new person, not the continue of Sue, but Huang is the continuing of Minkyu. And this is, as you see, this is, for example, you can use this one, but it will lose some important information. But this one, it stores information. Features for sequence like this. So what can be the features? So if from machine learning, classical machine learning, you should remember that actually when you're trying to train machine learning algorithm, you are, first of all, you should make features, and here we have, so what will be the features in this thing. So it will be current word, so it word itself, because maybe Google you can say, if it is Google, you can do previous next word, also important, because if it says it is located in, so if it is previous word in, or if you take window of two size, so actually you can say that if the previous two words was located in, then it is most probably location. And for example, he made something to specific to words, it means that it may be the person, etc. So you can train it. Other kinds of inferred linguistic classification, part of speech text. So you can make part of speech. Part of speech is like, is it noun, preposition, or something like this. It can be located, for example, for previous words. So for example, so in training you have in, but in testing you have to, for example, these prepositions, but it hadn't see the word to before some location, but you hadn't say that it can learn that in and to are preposition, and by that features they can understand this thing. Label context, previous and perhaps next label, so it also can be used. You can use if previous word is considered as other, or person, or location, or something like this, but there may be some features that are not like. Also, one very important feature which makes it much more like clever, it's word substrings. So most of words, they have some common features, like the cotrimoxazole. Mostly you will understand. So from the name, you do not know what is this one, but from the name you can understand that this is some drug, and because it contains some, for example, some substring like oxa, zole, etc. So you can take substrings and train on them, even if you do not specify this one. And for example, Wethersfield. Okay, Wethersfield. If something ends with field, it must be some location or maybe company. Less probably that it is person. Maybe it can be movie. And sorry.